Welcome to Integrated Math 3. On this episode, Stevenson will demonstrate. In this last example, I want to show you kind of a special case of quadratics in factored form. This sometimes come up, and because it doesn't look like what we're used to, we can sometimes get a little, maybe a little less confident with it. But I'm going to show you how to handle this. So let's look at h of x. Now, the first thing that should stand out to you is that we only have one set of parentheses. And remember, Stevenson, you told me that if it has two sets of parentheses in its factored form, well, really what you have to think about it is it's a quantity of x times a quantity of x. Thus, it's in our factored form, okay? Because x times x will be x squared. So if you think about it, even though there's no parentheses here, it is still a quantity of x times a quantity of x. If it makes you feel better, you can rewrite it like this. Okay? So if there's nothing there, it just means it's plus or minus 0. And actually, it doesn't even matter. You can make it minus or plus. It really doesn't matter because it's 0. So let's go through and analyze this like we've been doing. So my a value is the leading value here, is going to be 1. And my first root, we can use the first one here. And it doesn't matter if it's plus or minus because it's going to be plus or minus 0. And remember, 0 doesn't have any sign, so it's automatically 0. And this one, since it's plus 2, I go up here and I realize if it's plus 2, then I do the opposite of it, which is negative 2. That'll make a little bit more sense later when we get into factoring and review that. So let's analyze this. This is going to be concave up because a is greater than 0, therefore it is up. Its x-intercepts are, so remember we're going to follow this form right here, is going to be 0, 0, that should look familiar to you, and negative 2 comma 0. So now we have our two x-intercepts. And from there, do you remember how we find the axis of symmetry? Let's make a prediction this time. Let's see if we can do it. So if I'm like 0 and I'm at negative 2, what is that distance? That total distance is 2 units, correct? So what would halfway be between 0 and negative 2? Answer, negative 1. So let's see if we were right. So let's turn this one on and see what a graph looks like. All right, so here's our x-intercept, cool, so we have right here, and check it out, there's our vertex, which means that first negative 1 is our axis of symmetry. All right, so vertex is negative 1, negative 1. And let's do domain. Well, I'm running out of paper here. Domain is, of course, all real numbers. Range, okay, so, whoops, so the range, let's think about this. It has a minimum. So if it has a minimum, that means the lowest possible value is negative 1. And this particular value right here is negative 1. So I'm going to include it. So it's negative 1, comma, and it goes to positive infinity. Just like that. Awesome. Let's see, what's next? What's next? Vertex, range, domain. Oh, y-intercept. Okay. Well, the y-intercept would be right here, and it's the origin, which we probably could have figured that out from the beginning because remember I said in one of my earlier videos, if your graph ever goes through the origin, then it's going to be both an x and a y-intercept because it's a double 0. Okay, let's look at last thing, increasing and decreasing. So we read it left to right. So starting at the left here, negative infinity, as I go along my x-axis, I can see my outputs are decreasing. So my function starts with decreasing. So I'm going to start there. So it's negative infinity. And remember, we use the x-coordinate of the vertex. Now, I know this can be a little confusing in this example because they're both negative 1, but look back at my previous ones and you'll see that it's the x-coordinate that I use. So it is from negative infinity up until negative 1, not included. And then from negative 1 to positive infinity, I can see my graph is increasing. So again, this was just a special case I wanted to show you based on how the function was originally given to us. So notice you can always do a rewrite like this until you get more comfortable with this form here.